Hi, I am Walter Minute and this video explains my entry for the Dare to Dream Different challenge. The name of the project is SvegliONE, that's a joke in Italian. This is a schema show the hardware structure for my project. As you can see, most of devices are connected via I2C. I have to translate voltage because the Tahoe board is 3.3 volt and the devices are 5 volts. I got a real-time clock to keep the time, and then I/O expander that is connected to a sound generator that is used to generate some funny sound effects to wake up the people. I got also some LEDs connected to the PWM of the Tahoe board, but I can show them in this demo because they give me a problem when I try to connect them. This is software scheme and shows the kind of information this device retrieves. It retrieves calendars, RSS feed, and weather information and forecasts. We got a parser for each type of information, a parser for the icon format for the calendars, a parser for the RSS feed based on XML. It's a very simple parser, so we can parse both 1.0 and 2.0 feeds. And we have a weather bug information parser that passes the weather information and forecast that are retrieved using the weather bug APIs that are still based on HTTP. So this device is able to retrieve a lot of information from the internet and show it on a very easy to use user interface on that small display. I am mostly a software developer, but I usually work on Windows CE, on low-level drivers and BSP, and this is one of my first experiences using this kind of high-level languages and tools, and I think they are quite powerful also for the embedded world. I'm a software guy, so don't look too much at my hardware. Now we are going to see how all this information collected from the internet is displayed on the main UI of the device. Here's the UI. I'm sorry for the quality, but my webcam is not that great. We have the time, the main information in the middle of the display. We have the weather information on the top part, some news in the low part that change periodically, and in the middle we have the current date and the next alarm date. Now we can see the weather forecast. We have to click on the current weather information, and we can see the forecast for the whole week provided by the weather bug. We can scroll up and down and get all the information we need. Then we can go back to the main menu, to the main UI of the device. Clicking on the bottom side, we can see the news. We have the new feeds we are collecting. We can click on a feed and read the articles. We can go back and forward in the list of articles of our new feeds. We can go back and read another one, and so we can retrieve some useful information, some useful news from our device. The panel on the right side shows the dates, and if we click on it, we can open the calendar, and in the calendar we can see our appointment, deadline, etc. Oh, tomorrow we have an important deadline. Oh, it's the end of the Dare to Dream Different challenge. I have to remember to submit my video. If we have an alarm connected to an event inside the calendar, we have this small icon that reminds us that this is an alarm. We can increase or decrease the number of information we have on our screen. And now let's see our device in its full glory inside this yellow box. This is the main device. We can interact with it using only the touchscreen. We have an Ethernet cable that is used to retrieve the information from the internet. Now it's connected to my laptop that bridges the connection to my Wi-Fi home network, and the USB cable to power the device. Now let's see the hardware inside. We can open the box. This is the Tahoe 2 board. It's connected to another board inside the base using an old cable taken from a floppy drive. On the back of our device we can see two LEDs and a light sensor that are still not currently implemented inside the software. And we can open up our box and can see what's inside. Okay, we have a small speaker used for the alarm. It's connected to the sound generator, and we have the main board. Oh, as you can see, my soldering skills are not so great. We can close up our device and let's see how it runs. But before, we have to open up our calendar inside Windows Live. As you can see, we can have appointments and everything. To trigger an alarm inside our software, we have to use this tag, wake me, between squared breaks, and if we specify a number, we can pick up one of the 6 sounds that our device can reproduce, and so we can choose how we want to be waken up by our device. Okay, let's see this demo. Now I'm setting up an event with an alarm close to the time to the current time. I go to Windows Live, create my event. Okay, and now we have to wait because the device is polling my calendar, so just to avoid one boring minute waiting for the polling. Okay, we started the video, and now you can listen the original sound to hear the alarm. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and that's the alarm. You can press the snooze button and delay the alarm for 30 seconds. Now we can go back to sleep. And after 30 seconds, the alarm will begin. Okay, it's time to wake up so we can switch it off. Okay, let's see the things that I didn't have time to implement. The first one is the battery. It's not a matter of time, but as I told you, I'm mostly a software guy, so I didn't want to connect 2 power sources to the only working device I got. The CF77 is meant to synchronize the time over the radio waves, but it seems that reception in my area is not so good. It's broadcasted from Germany and I am in Italy. I didn't have time to implement the light sensor, but it can be used to dim the display backlight when someone turns off the light, or to change the color schema of the display to make it more readable at night. Temperature reading seems to be a little erratic on the device. I have a huge variation of temperature in a short time, so it's not readable on the Tahoe 2 board that I got. And lots of other features came to my mind while learning how to work with this kind of tools, but I have no time to implement them. I have a lot of people to thank for this work, for supporting, for providing me information, hints, and some source code also. And also I have to thank Microsoft for this chance to learn this new language, this new tool, that it's a very different way to work on embedded devices.